as or yesterday.
I thought it was pretty easy.
Yeah, it looks good. So
Honestly, I didn't do the homework again, but I studied the lesson and the videos, and I thought it was pretty easy.
mhm. I haven't done the homework yet either. By review, everything like the assignments. You know how the
Uh-huh.
assignments are. So I saw those and how it's done. So hopefully that's that's gonna help with the quiz.
Okay, should we start?
Yeah, yeah. Let me open. I'm opening the start the quiz. Okay. I created some like document with an Excel file, so I can just plug the numbers and get. Oh, do you know how they also provide one Excel file for you to
Uh-huh.
just plug the numbers and get the results. Um, I didn't see the new ones, the new formulas, so I just created one. Okay, let me see. So number. Let me get a pencil. Yes, I like to write things while. Okay, so we have the applet.
Can we start?
Okay, number 3. So find the margin error of a 90% confident interval when the standard deviation is 50 and the number sample is 25. So the margin error.
Okay, so when is 90, we're gonna use 1.645 as our z-score.
Yes, that's correct. Okay, so U
So
is
we can do
so U is 15 and N is 25 and C is 1.645, right? So um,
what is our
the margin of error for me, or like the one that I'm looking at, it's 16.45.
no.
So because so the question is find the margin of error. Uh, so the formula for margin of error is the z
No, the formula for margin of error is 1 point. Oh, okay, you're right. Wait. Okay, give me 1 second. Let me do it again.
Sure.
Mhm. I got 16.45.
Yep, me too.
Okay.
Okay.
Okay. Which of the following statements true? Standard deviation squared is an interval estimator of x. No, wait, I wrote this down. Let me find it.
So so x it's sample or the mean, the point of estimate.
You think number 2?
X. Yeah, I'm thinking number 2. Simple name. Good. Oh, his population standard deviation.
Wait.
Okay, hold on. Confident interval.
I think the mean is a point estimator of X. Because I'll show you. Can you see my notes? So like here is the draw that there was in the book. So there is the mean in the middle. And then here it's like how many standard deviations the X will be from the mean. So I think the mean is a point estimator for X.
Shouldn't be the opposite. X is a point estimator for U.
Because like the U is kind of the origin.
Yeah.
And then we will see how many standard deviations are a way to define X. I don't know, what do you think? That's what I wrote down, but I'm not like 100% sure if I'm interpreting this the right way.
Because what I put when I was putting my note, the X is a simple mean upon point estimate. I'm not sure what I wrote out. Point estimate.
Yeah. So let's go with yours.
So 2?
Yes, let's go for 2.
And I think it's we're learning that one, that they were gonna ask for that one, maybe.
Yeah.
Okay, so number 5. Gina wants to construct.
Oh, sorry. To construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size 64 and computes X equals 6 to 6. Use this information to the next question. What is the point estimate for true GMAT score?
The point estimate is gonna be the same always, like 526, right? The X is always the same. The point estimate. That's what we're gonna estimate from.
No, I think that's what you're saying. It's the confidence level. The point estimate is another thing. The point estimate
is where you go
the
from.
Equation, P. That it will be like 2 numbers. Remember?
No, that's the confidence interval. When we start like the confidence interval is the 2 numbers.
Yes, there is good.
But it's not asking for the confidence interval. It's asking for the point estimate. So in the assignment, it was asking that. That was like one of the first questions. Let me see. The preparation, like assignment, always ask for the point estimate, and it's usually the same as the
percentage.
No, not the percentage. So it says, what is the point estimate for the population mean? And it's supposed to be, what is the point estimate for the true GMAT score? So that's the point that, like we're gonna go from or base the X 526. Let me, no, I don't think I can see. I can show you my screen. Let me see if
I think the point estimator is 5 to 6.
Yeah, me too. 5 to 6. Yeah, that's what I was trying to explain. Okay, so number 6. What is the margin of error for the 95 interval? Okay, so I have my computations.
So let's do
X is 526. The standard deviation is 113. Sample is 64. And the let's see. Do you want a 95? So 95 is 1.96, right? 1.96.
I got 27.685.
Okay, fine. Yeah, me too. Okay, let me plug that.
What is the lower limit of this confidence interval? Okay, now we do that thing.
Yeah, now we do the whole thing.
So first we do
we subtract.
we do you wanna
the 196 minus the 520. I'm sorry. 526 minus and plus the other one. So for me, I got 498.315 and 553.605.
So yeah, I got to 498.315. Let me do the other one.
You know, it says what is the lower limit. So it's asking only for one of
so just this one, okay.
The 498, right?
Yeah, 0.315.
Yeah, because it doesn't get like two different. I think the answer doesn't let you have two answers.
Yeah, I got it. You're right.
So number 8, what is the
upper limit? Now we're do the plus.
0.3 decimals. I'm sorry. The upper limits, yeah. So it's 553.685.
Just a second.
Yep, you got that one too. 553.
553.685.
Yeah, perfect. What would happen to the width of the confidence interval if Gina increased the sample size? So I wrote that because that was interesting. So the sample size increases, the width of the confidence interval decreases. So did you write the same? So it decreases?
Let's show a greater z-score, which will increase the margin of error.
So I would say decrease. The width of the confidence is the one that I was asking for.
Oh, then it will decrease.
Yeah, I think that's the answer. So number 10, what will happen to the width of confidence interval if Gina changed it to 99? So when the margin of error, because it was 95, right? So it's increasing. The level of confidence is increasing.
I think it will decrease.
When the level of confidence increases, the width of the confidence interval increases.
My note says, if the sample is increased, the width of a confidence interval will decrease.
Yeah, that was the question before. So now what it's asking, what will happen to the width of the confidence if Gina changed the confidence interval? So it's not asking for the sample size, but the confidence interval. So what I wrote is, as level of confidence increases, that is what it's asking, the width of the confidence interval increases.
Okay.
11. Rye Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95 confidence interval with a margin of error of 50 hours. What sample size? So now we have to get a sample size. So standard deviation.
We can do z-score.
95.
I have a formula for sample size.
Me too.
Okay.
The margin error is 50. So if it's 95, then we're asking for 1.96. So um, 1.6 and 400 standard deviation. So
if it's positive, I got 64.629.
But it's asking for the N, right? So the N formula.
65.
I got the sample size is asking for how many they have to test for N.
That's what I got.
So I got 245 and A62.
Because the sample size formula is z-score plus or minus standard deviation dividing per margin of error squared, right?
I don't have the minus. I
You
don't have the minus. I just have z-score that it would be, in this case, 1.6 times the standard deviation 400.
Oh, you put times?
Divided by the 50, the margin error is square root of to the second exponent.
Wait, maybe I just copied wrong. So let me do it again. Yeah, 245.86, but because it's a
it's a sample, so we have to round it
we
to
need
the
to round up. So,
right. So 246.
246.
Good catch. Okay. So the mean salary of actuaries is 100,000, and the standard deviation is 300. The population, I'm not sure if it's higher or lower. So I'll do hypothesis test level of confidence. Is this from last week?
Yes.
With level of significance. Okay, so he's like, wait a minute.
What is the lower limit of this? 95% confidence interval. Okay, the lower limit. Dude.
Okay, so U is 100,000. Standard deviation is 36,700. Whoa. This higher lower. Okay, so the margin of error, the level of significance for them is 0.45, which is what we want to try to prove. So you collect simple random examples N36, and the X is 111.
So are we going to use 100 or 111?
111. Because that's the X.
Right?
Because that's the one that we're trying to prove, or the hypothesis. Is what I think. Just let me see. So X is 1. The deviation 36, 730, and 36 for 95. 95 is 196.
How much did you get?
I'm still checking. It's hold on. So the confidence interval, the first one is 99. No, 900. Whoa. No, 99,001.5333. That's the lowest, and the highest 122.
Oh, wait, I
99,
don't know.
8,
Again.
67. Okay, let me see something else. So
Okay, for the first one, I got 99,001.533.
yeah,
Is
me
that what
too.
you got?
The second one is 122,998.6, no, 467.
Oh, I didn't do the second one. Just a second. One two two nine nine eight point 467.
Mm-hmm.
Is that right?
467, yes. So the lower limit then should be the first one, right? 99,001.553. Oh no, rounded to the nearest whole number. So
Wait, which question are you?
12?
Which question are you, Julia?
12. Is that where we are? 12?
12 is 99,001.533, right? That's the answer.
It says to round it to the nearest whole number, so it should be 2. 99002.
Yes, you're right.
Okay. And 13 now, what is the upper limit? So should be also rounded. So 1.
That one we don't round to 9 because it's a 4.
But it says to round it to the nearest whole number.
Yeah, so it's 122,998 because the number that comes after is a 4. We just round for an upper number if it's up 5. So because
Okay.
it's a 4, it's 122,998.
Okay.
Okay. There are 3 requirements that need to be checked when computing a confidence interval for me.
Oh yeah.
They are a simple random was drawn for the population, that's right.
Mm-hmm. Second one is known. And
No.
Okay, so simple random sample is simple random sample. That's confusing.
There are true requirements that need to be checked to accompany confidence from the a simple random sample.
Popular deviation
It's
is known.
all of above.
Either of these conditions are satisfied.
It's all of the above.
Population, yes.
Right?
Yeah, that is right. All of the
Okay,
above.
let's submit.
Mhm.
Yay! 100.
Okay. Well, mine's still submitting.
Good
My
job,
process is doing-
Julia.
Good job,
You
Camila.
made it.
That was, I think this one was one of the fastest that we have done, huh?
Yeah.
Nice.